My name is Jim Horman, and we're going to talk about the biology of soil compaction. We've got a few problems here this morning, but I understand this may go off at noon, so I'm going to speed it up just a little bit. You know, when we talk about ideal soil composition, roughly 50% of the soil is what we call solid material. About 45% of that is the mineral portion, and in an ideal soil, we have about 5% organic matter. A lot of farmers don't know this, but as much as 50% of the soil can actually be pore space. However, when we compact the soil, a lot of times we don't have that much. So let's take a look at a compacted soil, look at some different bulk densities. If you look at an uncultivated, undisturbed woodlot, typically the bulk density is anywhere from 1 to 1.2 grams per centimeter cubed. And what we're looking at is we're looking at the weight and basically the weight over a volume of soil. And so that would be ideal. If we had 1.2 grams per centimeter cubed, that would be an ideal soil. We have about 50% pore space in that. But as we get into cultivated clays and cultivated sandy loams, you'll notice that the bulk density increases, and that means we have less room for air and water to move. And so if you look on my right-hand side there at the bottom, once we reach a bulk density of 1.6 grams per centimeter cubed, it starts to become root limiting. That's somewhere around 250 pounds per square inch. If we get up to 1.8, and then the roots are totally restricted, and the roots can't get through there. So that's real important. On a lot of our soils, we're actually limiting the roots and how deep they can go. So let's take a look at what is typical in our